All right, so answer quickly and accurately. Let's begin. Six seconds. Ooh, okay, so this was just what we were talking about just a little bit ago. If you tried to use the nth term test, you would take the limit as n approaches infinity and you would get 0. And unfortunately, that means that the nth term test is inconclusive. So you can't use it to show divergence. So that would be the correct answer here, is that you can't prove divergence. Excuse me, you can prove divergence by every test except the nth term test. So that was the point of this problem. Well, let's see who our early leaders are. Josh, okay. Pretty tight down there. Not too many separating some of the people on our podium. Let's continue. The key thing is answer most completely here. Five seconds. Okay, geometric series, certainly it's a geometric series. No one bid on the nth term test, but the most complete answer is a geometric series and the nth term test. You had 2 pi over 3 to the nth power. So let me cut out here for a second. So 2 pi over 3 to the nth term, that's a geometric series. You have a fixed ratio to some power. So that's a geometric series. The nth term test works. Why? Because if you take a look at the limit as n approaches infinity, that limit is not 0. And if it's not 0, then it can't converge. So you can use the nth term test to prove divergence. Why is it divergent by the geometric series? Because 2 pi over 3 is greater than 1. So it's convergent either way. Both methods can be used to converge. And let's see where that puts our finishers. Let's see. Josh still up top. Logan hanging up there in the hollowed high five. All right. So cool. Let's keep going. All right, so if you're familiar with me, then which one of these should you just throw out right away without even really thinking about it?
Telescoping.
Direct comparison.
Yeah, direct comparison. I mean, it's an okay test. It's just it requires a little bit more care than people seem to want to take on an exam. So I don't like that one. Telescoping series test, well, it's not going to be that one either, because the denominator is not going to factor. It's the sum of squares, not the difference of squares. So you're not going to get any telescoping, cancellation, etc. How about a p-test? How come it's not a P series. Well, P series looks like this, 1 over n to the p, and that's not what we have there. So it's not a P series. So kind of by process of elimination, you run around to the limit comparison test. So, okay. Let's take a look at the next one. Or no, let's take a look at our standings. Any bets? Any bets? Logan, are you still up the top? Oh, somebody passed you. You're still up the top, but Sophie going up there. Sandra and Ashley. Oh, Ashley's on fire. That's what this means. I think it means you got like 3 in a row. So cool. Keep it going. All right, let's keep going. Which one can't you use? Okay, so the answer I was looking for is that this is not a geometric series. So yeah, you shouldn't be using geometric series with this one. That was the one I was looking at. I certainly have sympathy for the nth term test one. Although the nth term test, let's see, would be inconclusive on this one, right? Because the limit would go to 0. So let's see, did I have that thing set up right? You can't use, yeah, I really should probably take credit for the nth term test. Although geometric series is the one that I was looking for the most because it's just not a geometric series. And maybe we should take a look at what those are. So the general form of a geometric series is a sub 1 times r to the n minus 1, n equals 1 to infinity. Now that a sub 1 is a constant, so it's this number, this ratio that you multiply to get from one term to the next, that's fixed. And that just wasn't the case with the problem we just had. We had some roots and stuff like that. It didn't fit into this pattern. You're supposed to have something to a fixed power. And
what was the original problem? Can I see it one more time?
You know, I don't know if there's a way I can go back. I think it was.
No problem.
You know, and I meant to write it down. I didn't think of it fast enough. But I think
I can just watch the video later.
The square root of n squared or something like that, and 3 here.
It was 100 over 3 times the square root of n squared.
Yeah, there you go. So, and unfortunately for me, this doesn't, or this cancels, and we end up with something n equals 1 to infinity, 100 over 3n. And the nth term test would go to 0. So the nth term test is inconclusive there. So I owe a few of you guys some points there. Sorry if that keeps you off the podium. All right, but let's see where things are at. Okay. All right, so that made it a little bit tighter here at the top. Four players have a streak of 4, so good on you guys. Three seconds. Okay, so kind of going back to Well, I'll tell you what, let's take a look at the problem first. And this time I did write it down. 2 to the n over 4n minus 1. And so this was our series, and let's see if we can eliminate things first. So one thing that it's not is a telescoping series. Telescoping series, you're going to have something like 1 over n minus 1 over n plus 2 or something like that, so that when you expand things, they'll cancel out. Now, typically it won't be written like that. Typically, you might see something written like 2 over n times n plus 2. And if it's something that can factor with partial fractions, then it's got a chance of being a telescoping series. So it's not a telescoping series. This 2 to the n power looks suggestive of the root test, but in the denominator, you can't take the nth root of that and simplify it as like 4 or something like that. It's just not going to simplify. So it's going to be kind of a drag to try and work with that under the root test. Integral test, yuck. I wouldn't want to try and have to integrate that. I don't know if it's possible or not. Maybe it is, but so that's kind of leading you back around to the limit comparison test. Now the limit comparison test, boy, this looks really close to something that we actually simplify very nicely. And can you see what that would be?
1/2 to the nth power.
Excellent. And let me help you out in case you didn't quite follow all that. This is going to be really close to 2 to the n over 4 to the n. If I didn't have that minus 1 there, then it would look like this. Now, let's take the nth power outside of things. And if you notice, Sandy already did this for us. She reduced that to 1/2 to the n. What do we know about something like this? That's a geometric series with r less than 1. So that's going to converge. So with a limit comparison test, yeah, you can do that pretty quickly with a nice limit comparison test. That would probably be the best one for that one that I would see. All right, where are we at? Oh no, Sophie, sorry to see you go. Logan, long time on the top 5, made it up to the top. Good for you. Still close, still anyone's game. Well, let's continue. All right. So this one is set up to be done by the integral test, but let's take a look through and see why we can eliminate some of the other ones. So it was 1 over n ln of n. To do the root test, I really should have something to the nth power. I should have something and then nth power on the outside. And that's when I should do the root test. But I don't have that here. So next one. Nth term test. Well, the nth term test is just going to go to 0. So let's think here. If it goes to 0, that doesn't show that it diverges. It just shows that it could converge, but it might diverge. So the nth term test doesn't really help us out on this one, so we can get rid of that one. The ratio test, is going to be actually inconclusive. If you did the ratio test, it's not going to work. You'd end up with a ratio of 1. So kind of by process of elimination, you get back to this, the integral test. This one looks like something that I think my son can expect because he's taking a calculus test this week. If you had 1 over x, ln x, dx, the tricky thing about this one is the u substitution that you need for this one. U equals ln of x, and the du term is going to be 1 over x dx. And we actually have that. So what you'd end up with is the integral of 1 over u du, which is the ln of u. And then you'd have to put in ln of x, so you'd have the ln of x. So, kind of a strange one. Eventually, this thing is going to diverge.
And those are absolute value bars?
Yes. So eventually, this thing is going to diverge. And the amazing thing is that it diverges even slower than the harmonic series, which is 1 over n. So, okay. Let's see how we're doing on this one. Or where let's put this. Okay. Yeah, I'm not sure what happened to the music. Ryan, up 5 spots. Well done, Ryan. I don't know. Maybe the website got tired of putting in the music. Not sure. Let's keep going. A few more here. We're halfway through. Oh, there's the music. Cool, well done. Well done. Yeah, use the alternating series test on this one. The reason for that is because the limit of the terms, the nth term test, let's see here, sum from n equals 1 to infinity. Well, the nth term test is not there, at least directly. 3 to the n over n times 2 to the n. I believe ratio integral root test, ratio test, integral test, and what else do we have? Alternating series, AST. So let's again look at all these three. Let's see, what's going to happen with the ratio test? Not so sure that it might work, but I think what's going to happen is you're going to end up with a 1. But let's focus on the correct answer here, the alternating series test. What has to be true if something is going to converge by the alternating series test or diverge? Well, the limit as n approaches infinity of these terms, absolute value of a sub n, has to go to 0. So we can forget about the alternating part. The terms themselves have to eventually get to 0. And that's not going to be true with limit as n approaches infinity of 3n over n times 2 to the n. It's going to be greater than 1. So, hate when that happens, but it's not going to converge. So, all right. A new leader, Josh, well done. Chris moving up. All right, Sophie and Maria also moving up. Good to see. Oops. Oh. We just did this one, and the answer was that it diverges. So,
Hit the wrong button.
okay. All right. So, quite a mix-up on the leaderboard. I don't know. Did anyone catch the last answer on that one?
I
No.
believe it was Detroit Lions to the negative infinity.
Yeah. All right. So, bye-bye, Matt, Patricia. Who knows what's coming up next? Okay. So let's look through and do this one by process of elimination. Integral test. So with this one, I think the thing to do is to try and eliminate some choices. And why can we eliminate this first one? What right off the bat says, oh, you can't do it with this test?
Not a P test or not a P series.
Thank you. It's not a P series. So you eliminate that one right away. All right, someone else for the next one. How come I can eliminate this one?
It's not in a geometric series.
Yeah, it's not a geometric series, so you can eliminate that one. So now you're down between ratio and root and ratio and integral. And since both of them have ratio, then it's root test versus integral test. Ask yourself this question. Do you want to integrate that? I'd say no.
Golly, that doesn't look fun.
No, it really doesn't. So if you don't want to integrate that, then ratio and root test, and both of them look reasonable. I mean, you've got something to the nth power. That nth power is kind of like on the outside. I could rewrite this as 6 over n plus 1 to the nth power like that. And now the root test would look fine. The ratio test would also probably work okay there. It'd be a little bit more work than the root test, but it'd be okay. All right. So where are we at? Josh, starting to pull away a little bit. All right, so this will be our last one here. Let's take a look at this one. Ah, well done. All right, so a lot of people got this one right. That's what I want to see. Arrow tests and telescoping series. So let's take a look at things here. You know, and again, it's just a matter of throwing things out. It's not a P series. Okay, cool. It's not a P series test. I don't think I want to integrate that. It's not telescoping, so ratio, not ration.
Is there actually an integral for a factorial?
Actually, there's kind of the reverse. The gamma function is the integral of something. I can't remember the exact function right now, but for integer values, it is n minus 1 factorial for integer values of n. So, so it is related to that. Integrating a factorial, wow, good luck. No thanks. So let's see where that last one put us. All right, all right. Melissa catching fire again. I'm going to end things here. So I hope I get some results. On the podium, Anthony, well done.
Woohoo.
Ashley, and our winner. Who is it? Who is it? Josh, well done, well done. So, all right. Awesome. Thank you all for playing. I'm going to stop the recording.